This is an HVAC actuator. This actuator is used in GM vehicles to adjust certain things in your climate control system. It can be used to adjust the temperature or redirect the airflow from like the floor vents to the defrost vents, or it can change between inside air and outside air. When there's an issue with these actuators, it can be difficult to diagnose them because it's often difficult to get to probe the backside of these connectors. So I made this HVAC actuator tester. Another issue is when there's a malfunction with these, it'll set a diagnostic trouble code and the control module will disable the output, so it won't even let me test it a lot of times. This tester allows me to override the control module in the vehicle. So assuming I can even get to the connector, I can unplug the vehicle harness, plug my tester in, and I can manually drive this actuator with this tester. In the tester display, you see the position sensor voltage inside this actuator, and I'm also able to display the minimum and maximum values. I have a reset button, allows me to reset the position sensor minimum and maximum values. This is helpful because I can confirm that the actuator can even move and that I don't have a physically stuck door. And it also shows me that the position sensor voltage is working correctly. So let's take a look at the schematic for this HVAC actuator tester. The circuit is powered up with just a 9-volt battery. We have an on-off switch, an Arduino Nano, a linear 5-volt regulator, 16:2 liquid crystal display. We have the reset switch, and over here on the right we have a two-way rocker switch and a couple series resistors. And the way these actuators are operated is with 2.5 volts on this control pin, the actuator will remain at rest. If the control pin is driven to 5 volts, it'll rotate in one direction, and if it's driven to 0 volts, it will rotate in the opposite direction. So we have these two series resistors here with 5 volts on the top and ground on the bottom. So when this rocker switch is in its rest position, we'll have 2.5 volts here on the control circuit. When we press the switch up, we apply 5 volts to the control circuit, driving the motor in one direction, and when we rock the switch down, we ground the control pin, causing it to rotate in the opposite direction. So what the Arduino is doing here is it's just looking at this position pin. This is just attaches to the internal potentiometer inside that actuator that gives the position signal. So we have that analog voltage going into the Nano, and the Nano displays that voltage on the liquid crystal display. In the reset switch, we just have an input here into D13. When you press the switch, we apply 5 volts to D13, and then when the switch is open, we have a pull-down resistor here that ensures that D13 does not float. This is just this pot here just adjusts the contrast on the liquid crystal display. Now, I'm not even sure that this 5-volt regulator is even necessary. We do have a 5-volt output here on the Arduino Nano. I was just a little bit concerned that operating all these devices on 5 volts would place too great of a current demand on the Nano. I suppose I could go through and measure all the current draws from all these different devices and check to see if the Nano in the data sheet could handle that much current, but I have not done that. So I had these 5-volt regulators laying around, so I just added that to the circuit to reduce the current demand through the Nano. Alright, let's take a look at the code that I wrote for this tester. Up at the top here, I'm using a library to make it easier to use this liquid crystal display. The second line just tells the Arduino what pins I have attached to what pins on the display. And next we have some variables. Pot pin is the pin looking at the position sensor signal on the actuator. And then reset pin is attached to the reset button. These next 4 variables are for the displayed minimum and maximum values. And the current volts variable is for the current position sensor voltage. In the setup here we have we're just setting up the liquid crystal display, telling the library what kind of display we have, where we're starting our cursor, and printing some strings here. Then we also tell the Arduino that our pot pin and reset pin are both inputs, so it knows to look for an input there. Alright, in the loop here, the first thing we do is we take a look at the position sensor on the actuator and assign that to the current volts variable. Now this won't be a value between 0 and 5 volts because the Arduino uses a 10-bit analog to digital converter, so it will be instead of a voltage you'll have a binary value between 0 and 1023. So this next line takes that binary value and converts it into a number, a voltage between 0 and 5 volts, which is what we want to see. And then it takes that voltage number and prints it on the display on that top line. Now for the minimum and maximum values, we'll just take a look here at the minimum. First thing we do is we again look at that position sensor voltage and we convert it to a number between 0 and 5 volts. And then this if statement here takes a look at if this value is less than the old value, it will execute these lines of code. Now if you recall, up at the top here we've initialized old min at 5 volts, so that ensures that it will update the display with this new minimum, so because it should be something between 0 and 5 volts. So we've initialized old minimum at 5 volts. This should be less, so it forces this to run. So it prints this value here that reads on the position sensor for the minimum value. And then at the very end here, it assigns, it updates this old min value, which is initially 5 volts, to the new min value. So it comes back around, loops again, and it reads that voltage again, and if it's a lower value than what's being displayed, it will go back into this and update the display. And if the current value on the position sensor is greater than the old value or the displayed value, it'll skip over it. It won't update it. And the maximum pretty much works the same way. Down here we have it's looking for the reset switch. If it sees the reset pin go high, it will update the old min and old max variables, which is basically what's being displayed. It'll update old min to 5 volts and old max to 0 volts, which again, it basically forces these things to update, because this new min should be something less than 5 volts. It should be between 0 and 5 volts, so it'll take another look at the current value here, and it should force it to run by assigning a 5 volt value to that and updating the display with the current position sensor voltage. Okay, real quickly we'll show you how I put this thing together. The case is 3D printed. There's the rocker switch that controls the actuator direction, 9-volt battery. That's the reset switch for the min max, the on-off switch. In the center here, down in the bottom, is the back side of the display. And then I have all the electronics soldered to this perf board. So here we have the nano 5-volt regulator. This is the potentiometer that adjusts the contrast on the display. And these are the two 10K ohm resistors that give us the 2.5 volts to keep the actuator at rest when the switch isn't being pressed. And the board just sits down into this section here, and I hold it down with just a couple dabs of hot glue in the same way that I have the display held in. As far as cable management, I just use some woven polyester electrical tape and a zip tie, and it seems to work pretty good. So there are some problems with this. One problem is it only does one type of actuator, and GM uses several different styles, most of which it's obvious that this won't work with because the connectors are different. There is one style that uses the exact same connector that this will not work with. So that's kind of a major flaw. You got to get into the schematics for the car you're working on and ensure that it's the 0, 2.5, and 5 volt control. The other style uses it's like a window motor where the control module in the car provides 12 volts and ground directly to the actuator, and then when it wants to reverse the direction, it just reverses the polarity. So this will plug into that style, and obviously it doesn't work. If I was ever to make a version 2, I think I'd mentioned earlier I thought maybe I could eliminate that 5 volt regulator, but I think I would keep the regulator and actually eliminate the display and the Arduino. It's unnecessary, I believe. I think most technicians that would use something like this already own a voltmeter. With most decent voltmeters have min-max capability. So you could just break off a couple of test leads off that position signal and ground and solder some banana jacks to them, plug them directly into a voltmeter, and get your voltage reading on the position sensor that way. It would greatly simplify this. But I wanted to see if I could do it. It was more of an educational exercise than anything, but it does work, and I have used it at work. And so that's it. Thanks for watching.